Yes, in this part now I'm going to explain the properties of exponential functions, but you have to write this page. This way, maybe 1 second I'm going to wait here, and you're going to write all the things. You're going to copy these things to your notebook. 1, 2. You are going to find. You may find these pages also in Schoology in PDF form, so you may copy from that part, or you may stop your video now. If your quality is enough for that one, you may stop the video and you may write this page, then you may continue to watch the video. Okay, then here I'm going to explain only 3a and 3b. Here they are important because, and we are going to solve question about that one. Let's start with 3a. What does it mean? Here function a, if it is greater than 1, function is increasing. And what does it mean? We will try to understand that one. Here, if a is greater than 1, we solve the question about y is equal to 2 to the power of x. And you know, function is increasing, so here the values from left to right, when you move from left to right, you are increasing the value. So x1 and x2, here, if this is x1 and this is x2, 2 to the power of x1 is smaller than 2 to the power of x2 actually, and this implies that for the increasing function we are talking, x1 is also smaller than x2. It explains this one only. Okay, if a is greater than 1, here it's obvious, here function, it should be increasing function. So when you give two values, which one is bigger, x for the x I'm talking, if you choose x1 and x2, if x2 is bigger than x1, it means that function value there, the y1 or 2 to the power of x1 and 2 to the power of x2, you can compare like this. Okay, for the second one, if a is between 0 and 1, you know a cannot be negative. This is important. A cannot be negative. Minimum a value, it will be 0. Then here it should be the graph. If you remember, we have drawn two graphs. The first graph, it was 2 to the power of x. Second graph, it was 2 to the power of minus x. But you know this one, 2 to the power of minus x can be written as 2 to the power of minus 1 to the power of x, which is equal to 1 over 2 to the power of x. So here the a value, a to the power of x, if we are talking about a to the power of x, a value is equal to 1 over 2, and if a is between 0 and 1, the graph, it should be decreasing graph. So when you choose two value on the x-axis, if x1, here x2, but when you find the values, you see here the value is greater than this one, this point. It means that x1 is smaller than x2, but here ax1 is greater than ax2. This shows that if it is like this, this shows that a is between 0 and 1 for the exponential functions. Okay, for understanding the previous properties, we are going to solve these questions, and we are going to compare the numbers with 1, and is it greater than 1 or not. Why it is not asking, if you ask why it is not asking 2, 3, 4, only 1, because 1 can be written as 1 over 2 to the power of 0, or it can be written as 1.5 to the power of 0. So for these terms you can write, 1 as the base of 1 over 2, base is 1 over 2, base is 1.5 or 3 over 2, or base is root 3 to the power of 0, all these powers, or Also it can be root 3 to the power of 0 here. So when I want to compare one, I'm going to compare with respect to base and with respect to these values here, x1 and x2 values. If it is increasing function, it means that a is greater than 1. If it is decreasing function, it means that a is smaller than 1. Okay, let's continue. Now, a to the power of 1 over 2 to the power of 0.4. And here it says that the compare with 1 and find which one is bigger. Okay, for finding this one, I need to write 1 over 2 to the power of 0.4. I need to compare 1 over 2 to the power of with 0. I need to compare 1 over 2 to the power of 0 is equal to 1. You know this one. So which one is bigger? The previous property for the base between 0 and 1, here it is between 0 and 1 over 2. It says that if the base is between 0 and 1, which power is bigger, the value is less. Here it says that which power is bigger here, 2 to the power of x1 or 2 to the power of x2. You see, normally x2 is bigger than x1, but 2 to the power of x2 is smaller than 2 to the power of x1, which means the value here, if it is bigger, it should be smaller. Okay, if we solve the same question for the 1.5 to the power of 1.4. The number, it seems difficult, but compare with 1, greater than or smaller than. We are going to find that one. Okay, 1.5 to the power of 1.4 is going to be 1.5 to the power of 1.5 to the power of 0. It's going to be here because this is equal to 1. Then here for this one I'm going to draw 1.5. If it is 1.5, the base 1.5 is greater than 1, which means a is greater than 1. A is greater than 1, your graph, it should be like this. 0 is here, 1.4 is here. This is the power, a to the power of x. Okay, the x value 1.4 and 0. 0 is here, 1.4 here. So the values of the function here and here, which value is bigger? A to the power of 1.5 to the power of 1.5 to the power of 1.4 or 1.5 to the power of 1.5 to the power of 0. Which one is bigger? Of course, 1.5 to the power of 1.4 is bigger than this one. So this should be greater. Okay, now we are going to compare with root 2. Root 2 to the power of minus root 2. Root 3 to the power of minus 2. We can do like this. Root 3 to the power of, instead of 1, I'm going to write 0. Which one is bigger? Again, here, this is here, if I draw the graph here, when it is root 3 here, it means that root 3 approximately it's equal to 1.43. I remember like that, I don't know exactly. And when it is greater than 1, a is greater than 1, the function a to the power of x, it was like this. And minus 2 is here, approximately minus 2 is here, so this is root 3 to the power of minus 2, and this is root 3 to the power of 0, because here this is equal to, this point is going to be equal to 0 on the x-axis. So which value is bigger? Here, as you see, it's increasing. It means that root 3 to the power of 0 is greater than. I didn't write here, but 1 over 2 to the power of 0.4 is smaller than 1. Okay. 1.5 to the power of 1 over 4, pardon, 1.4 is greater than 1. And root 3 to the power of minus 2 is smaller than 1. Yes, here the rest it will be homework for you. D1 and E1 you may easily compare by 1 greater than 1 or not. Here you need to know only this one, 1 over root 5. This number here the a is smaller than 1, and 2 over 3. Here also a is smaller than 1. So you are going to use always decreasing graphs for that one. Decreasing graph and decreasing graph you are going to use. Okay, let's continue with the other question. Yes, here it says find the biggest number in each pair. Which one is bigger? Now, here the base a is 5 and it is greater than 1. So our function is going to be increasing function. I'm going to replace the 3 over 4 and 4 over 5. Which one is bigger? You know that one. 3 over 4. Normally, if 3 over 4, it's approximately 0.75 here, and I know that one, this maybe doesn't seem good graph, but approximately 3 over 4 and 4 over 5 approximately, not approximately, it's equal to 4 over 5 is equal to 0.8 it should be, and this is 0.75, 0.80. A is greater than 1, so which one is bigger? 4 over 5 is bigger than 3 over 4, so 5 to the power of 3 over 4 is smaller than 5 to the power of 4 over 5. Okay, here if we compare these two, 2 over 3, so base is a is smaller than 1. For this function we are going to draw, for these values we are going to draw this graph. A is smaller than 1 graph, this is. And here 5 over 2 approximately 2 point, not approximately, it's equal to 2.5. Here if this is 2.5 and 3, it's going to be here. And as you see here, if this is the 2 over 3 to the power of x graph, okay, 2 over 3 here and 2 to the power of 2 over 3 to the power of 5 over 2 here, 3 here. So 2 over 3 to the power of 5 over 2 is bigger than, this is 5 over 2, value is bigger than 2 over 3 to the power of 2 over 3 to the power of 3. Here it seems tricky question, but as a third grade 11 science student, third grade 11 science students, you can understand that here the power is negative, or here it is, this can be written as negative power. So firstly I need to arrange this one. 2 to the power of minus 2 can be written as root 2 to the power of minus 1 to the power of 2. This minus 1 makes our term 1 over root 2 to the power of 2. So we are going to compare 1 over root 2 to the power of 2 is greater or smaller than 1 over root 2 to the power of 3. For understanding this one, firstly we should understand here the a value that I choose is 1 over root 2, and this number is smaller than 1. If it is smaller than 1, function graph of this one, it should be decreasing graph. This is 1 over root 2 to the power of x. If x is equal to 2, x is equal to 2 here, x is equal to 3 here, 2 and 3. Which value is bigger? As you see, this is decreasing here, it continues to decrease, and 2 value, x is equal to 2 value, x is greater than x is equal to 3. So it means that this one is greater than that one. Here, this is greater. Here, this one is greater again. And here, this one is smaller. The first one is smaller.